transformations of a function, okay, here's our textbook definition. It says you can transform the graph of a function in various ways. You can translate the graph horizontally or vertically. You can stretch or compress the graph horizontally or vertically. And you can reflect the graph across the x-axis and y-axis. How the graph of a given function is transformed is determined by the way certain numbers called parameters are introduced into the function. Now, that's a lot of math jargon, and when I was in high school, if I read that, I wouldn't have understood what they were talking about. A transformation of a graph just means how is it going to move that graph? Is it going to move it up? Is it going to move it down? Is it going to move it to the left? Is it going to move it to the right? It could make it make it thinner or wider, and we'll talk about all of those different concepts and what changes a function to do that. So we're going to start with a basic function today. We're going to start with, this is called, and these are called, what we're going to be dealing with a lot today is, they're called parent functions. They're the very simplest form of a function. The one that's on the screen, this is an absolute value function. It's y is equal to the absolute value of x. And it forms a v. And this is the parent function because there's no numbers that are added to it. There's no other parameters to it. It's just the basic absolute value of x. Okay. Now the other parent functions that you'll get used to this year. Oops, I don't have my board plugged in right now. Okay, let's plug that in. Okay, so the other functions or parent functions that you should be getting used to this year. Uh-oh, my marker is not working here. Oh, there we go. We'll end up with y is equal to, let's see here, I need to get a color here. Let's do red. Y is equal to x squared. That is a parent function of a parabola. So that's going to look like this, and we're going to talk about that today. Y is equal to x to the third. This is a parent function of a graph that looks something like this. Y is equal to the square root of x. That graph looks like this. Okay, and these are called parent functions because you can know, like if I did x squared plus 3, that's not a parent function anymore because I just added 3 to the back side of it. So a parent function is just the very basic function, and then we can transform that. Okay, so now I'm going to take you to my Desmos calculator. I've got to share that screen with you, so 1 second here. I'll make sure I can share that, because if not, you won't be seeing what I'm seeing. Okay, so share application screen, Chrome tab, Desmos calculator, share. Okay, so hopefully Desmos calculator right now, and I have y is equal to the absolute value of x in here, and you can see the graph on and that is the parent function of an absolute value. So now I'm gonna add a number to the backside of this. I'm gonna add like 3, and it's like, okay, what does adding a number to that function, that parent function, do? And it doesn't matter if it's a parabola or if it's an absolute value or if it's it does exactly the same thing. When you add a number to the parent function, I don't care, or subtract, it's going to move the function up or down. That's all it does. So for example, if I said y is equal to the absolute value of x plus 3, I know, because I've been doing this for a long time, that adding that 3 is going to shift that graph up 3 places. So that's a transformation. I just shifted the graph up 3 places. So when you start realizing that all these numbers that you add or subtract onto a function just shifts it left, right, up, down, then you really don't need a graphics calculator anymore. As long as you know what the parent function is, it's like, oh, I know what that's going to do. Now, let's say I subtracted 2. What do you think is going to happen to this red graph? It's going to shift it down 2 places, isn't it? So y is equal to the absolute value of x minus 2. Hopefully it shifts it down 2 places. And look at it does. So I know that if I add or subtract a number to a parent function, it's going to shift it up or down. That's all it does. So let's take another parent function and see if it does exactly the same thing, because math is very concrete. I mean, the rules don't change. So let's go y is equal to x squared. Okay, that is a parabola. This is the parent function to y is equal to x squared. Let's say I'm going to add 3 to it. Y is equal to x squared plus 3. Guess what's going to happen there? It's going to shift that graph up 3 units. I don't care what the parent function is. Adding a number is going to shift it up. If I add 10, it's going to shift it up 10 places. If I subtract 5, it's going to shift the graph down 5 places. That is a transformation. Okay, so that's one transformation. So let's talk about shifting the graph left and right. Okay, well, if I had a parent function, let's just stay with x squared now, since that's what I'm dealing with. Let's say I put inside parentheses. So y is equal to parenthesis x minus 2 squared. Now, a lot of kids are going to say, oh, it's going to shift it 2 places to the left. Incorrect. It does the opposite of what's inside the parentheses. So if it's a minus 2, it's going to shift the graph 2 places to the right. If it was a plus 2, it's going to shift it 2 places to the left. I'll show you. I'll just change this to a plus sign. And look at that. It just shifts it. So now I know how to shift the graph left and right. I know how to shift the graph up and down. Does it work with the other parent function? Absolutely. It does not. Math is very concrete. I mean, if it's going to work for one, it's going to work for the other. So if I have the absolute value of x, here's my parent function. Let's see here. And I'm going to say, okay, I'm going to do the y is equal to the absolute value of x plus 5. Well, I know that's going to shift the graph 5 units to the left. Because it's a plus, it always shifts it to the opposite of what you think it's going to. So it's going to shift it 5 places to the left. How cool is that? So now, if I was going to give you a test, I would say, okay, I want you to graph the absolute value function, and I want you to write an equation of an absolute value function that is shifted 5 places to the right and 3 places down. Well, now you can use this Desmos calculator to see if your answer is correct. So I said 5 places to the right, didn't I? I think so. And 3 places down. And there's my graph. It shifted 5 to the left, or 5 to the right, I'm sorry, and 3 down. So that a transformation is all about. Being able to move a graph. Now, what happens if I put a number on the outside? Okay, so for example, let's say I started with x squared again. Okay, here's my absolute value function. Let's say I put, oh, I should have put y is equal to. You don't have to. I mean, it's going to graph it anyways. Let's say I want to put a number out in front. Let's say I put a 2 there. What is it going to do to this graph? Well, guess what? It's going to make it thinner because it's going to go up a lot faster. And I'll give you some notes in just a bit. So y is equal to 2 times x squared, and you can see that the black, and it's kind of nice. Desmos is real nice. So the purple one is the original function. The black one is the second function. So the 2 makes the function thinner. Now they call this a vertical stretch in our textbook. I always just say, oh, it makes it thinner. So let's say I make this number less than 1. What do you think it's going to do? Well, it's going to make it wider. So if I had y is equal to, let's say, 0.5 x squared, made it wider. So if the number is greater than 1, it's going to make it thinner. If it's less than 1, it's going to make it greater. It's going to make it fat. However, and that's between 0 and 1. You can't put a negative in there. Well, what happens if we do put a negative in there? What do you think is going to happen? Negative number, Mr. Shanklin? All right. So let's put a negative number in here. Let's get rid of these. What does a negative in front do? Okay, so we've got y equal to, let's go negative x squared. It flips it over. Oh my goodness. So a negative number out in front is going to flip your graph over the x-axis. That is kind of cool. These are called transformations. They transform the way a graph looks. And with a graphing calculator, I still remember when I was in school so many years ago, we didn't have graphics calculators, and when we started talking about transformations, we had to plot all the points and graph them out by hand. Oh, it was excruciating. And I didn't understand anything about how a graph moved left and right and up and down. But now with Desmos, it's like, wow, if I didn't know something, I would just put it into my calculator and I would check it out. All right, let's go back to our slideshow for today. Okay, so I've got to turn this off here. I've got to get back to my slides. Okay, so we were just talking about transformations, and we can use any parent function that we want. As long as we know what a parent function looks like, we can do it. So what am I going to give you this week that will really test to see if you understand what you're doing? Well, if I gave you this graph, let's say that this graph is f of x, okay? So this graph is f of x, and I ask you to graph f of x plus 2. Well, we know that the plus 2 is just going to move it up 2 places. So my new graph would be I would just move each one of these little dots up 2 places. And then my graph, if I connected these, this is what my graph would look like. What if I asked you to graph f of x minus 2? Oh, okay, well, the minus 2, that's going to move the graph, it's going to shift the graph 2 places to the right, isn't it? So I'm just going to take each one of these dots, I'm going to move it 2 places to the right. I should have did this in a different color. Sorry about that, guys. I'll change the color. Okay, so I'm just going to move it 2 places to the right, all these dots. Okay, so my graph would look something like this now. And that is like the first problem on the assessment this week. It's just basically, do you know how to shift the graphs around? Kind of cool, hey? I think it is. Once you understand transformations, as I said, I did not understand transformations in school. Okay, so here's the notes for today. Translation, vertical, up or down. If you add a number to f of x, it's going to move the graph up or down. So if you add plus k, it's going to move it up that many units. Okay, so that's moving graph up or down if you add a number. Okay, so if you add the number inside the parentheses, it's going to move it left or right. So if I did x plus 2, it's going to shift it 2 places to the left. If I did x minus 2, it's going to shift the graph to the right. Okay, and that one, most kids, they kind of mess up. They shift it the wrong way. You just have to always remember, whatever's inside the parentheses, it's going to move it opposite. Then if I put a number on the outside, this is where I call it thinner or, fatter or thinner. If the k value is greater than 1, it's going to make the function, it's going to stretch it on the vertical axis. And if it's less than 1 but greater than 0, it's going to shrink it on the vertical axis. It's gonna make it wider. Okay, and then and this is the terminology that you use. I don't get too much into the terminology kind of things. I just, if you understand that, if the number in front of there is going to be like a 3, it's going to, it's going to make it much thinner, I'm good with that. I mean, the terminology to me is not that important. As long as you understand what's going to happen to that graph, I'm good. And then if you put a number inside, if you multiply inside, they call these horizontal stretches and shrinks. So if the k value is less than 1, and a lot of times it's like, so it's going to horizontally make it wider or horizontally shrink it up. Don't really deal with those that often. And here's the terminology for that. Now, if you have f of x equals absolute value of x, okay, so here's the graph. Here's a couple problems that I would give you on a test. I'd ask you to do f of x plus 4. Well, f of x plus 4 just means that it's going to shift it up 4 units. So my marker's not working again. It's going to shift it up 4 units, and it's going to look something like this. Okay, 2 times f of x. Well, that means the slope is going to be 2 instead of 1. So that means it's going to look something like this. Try to get it a little better so you guys have a good day. Okay, if I f of x plus 2, okay, so plus 2, that means it's going to shift it to the left 2 places. So that would look something like this. these are real quick sketches. You're going to have to do a little better. And f of x minus 3 plus 2. Okay, so this is 2 transformations. It's going to transform up 2 places and then 3 places to the right. 1, 2, 3. So it's going to look something like this. So those are transformations. Pretty cool once you understand transformations. It's like you should be able to, you know, a graphics calculator is not needed anymore. You should be able to look at something and say, oh, okay, I should be able to do that. All right, a couple practice problems from this week. It says, how would the graph of the function y minus 8 be affected if the function were changed to is equal to x squared minus 3? Well, a quick sketch of that, okay, I know that this is a parabola. It's shifted down 8 places, so that's what I'm starting with. That's what they tell me I'm starting with. And then they said, well, how is it affected if it changes to x minus 3? So x minus 3 is way up here. So really, isn't it just shifted up 3 or 5 units? I mean, this graph to this graph is just shifted up 5 units because it started here at minus 8, went up to minus 3. That shifted up. The graph would be shifted 5 units down. Nope. The graph would be shifted 5 units to the left. Nope. The graph would be shifted 5 units up. Yep. I'll go with that one. Okay. How about this problem? It says compare the graph of g of x equals x squared plus 6 with the graph of x squared. Well, one of them is going to be shifted 6 units up, right? Because x squared plus 6 is, the x squared is the parent function of a parabola, and x squared plus 6 is just shifted up 6 places. So the graph of g of x is translated 6 units down. Nope. The g of x is wider. Nope. They're exactly the same. The graph of g of x is translated 6 units up from the graph of f of x. Well, that sounds about right to me. That it's just going to be shifted up. Use my marker here. I'll go with that one. All right. That is the first section of this week's assessment. Now, the second part is called inverse functions. Okay? What is an inverse function? Well, an inverse function undoes what a normal function does. So, for example, if I gave you y is equal to, 2x plus 4, and I said, and usually we write this in function notation, it would be f of x equals, but that doesn't really matter. Let's say I gave you x equals 2, and I asked you to plug that in. What does y equal? Well, if I put 2 in here, 2 times 2 is 4, plus 4 is 8. So when I 8 for my answer. Now, what does an inverse function do? Well, an inverse function says, hey, if you plug in 8, you should get 2 back out. It undoes what the original function did. So an inverse function is just going backwards. So how do we write an inverse function? Because that's what I'm going to ask you to do tonight. I'm going to ask you to write an inverse function. Okay? So it's super easy. Super easy. All you do is you flip-flop the x and the y around. Okay? So wherever you see y, you put an x. Wherever you see an x, you put a y. Okay? That's your first step. Second step, you solve for y. You want to rewrite this thing so it's y is equal to. So I would subtract 4 off of both sides. So I'd end up with x minus 4 equals 2y. And then I would divide by 2. So is equal to x minus 4 over 2. Now, it's really easy to check if your answers work, because what did we say? If we plug in 8 now, so if I put 8 in here, 8 minus 4 is 4. 4 divided by 2 is 2. I get that answer. This is called my inverse function, and sometimes we'll write it this way, saying that this is the inverse function of this. And it's really easy to check yourself, because all you have to do is plug in a number into the original equation, and then whatever you get, that's what you plug into the inverse function, and you should get this back out. That is what an inverse function does. So here are the steps. Substitute y for f of x. Okay, so if they write the equation as, every time I switch slides, I have to turn my marker back on. So if they write it as f of x equals 2x plus 3, the first thing you're going to do is you're going to just write it as y is equal to 2x plus 3, because f of x does stand for it. Okay, solve for x in terms of y. So basically what they're saying is flip-flop the x and y around. So x equals 2y plus 3, and then you're going to solve it. And then when you're done, you're just going to say f inverse of x is equal to whatever you solved for. Super, super easy to do. but that's what an inverse function does. Okay, and when you graph an inverse function, you'll see that they're reflections about the line y is equal to x. So what does that mean? Well, the line y is equal to x is this line right here. Okay, because if you think about it, this is really y is equal to 1x plus 0, so my y-intercept is 0, my slope is 1. That's the graph of y is equal to x. And now if you folded your graph along this line here, this graph and this graph will meet up. They'll cross right over. They're mirror images of themselves. That's what an inverse function does also when you graph it out. All right, so let's try a couple practice problems. It says solve for the inverse function. Okay, so they gave me f of x equals 7x minus 5. Okay, so if I'm going to solve that one, so I've got y is equal to 7x minus 5. I'm going to flip-flop the x and y, so x equals 7y minus 5. I'm going to solve this. I'm going to add 5 to both sides. So I end up with x plus 5 is equal to 7y. And then my last step would be to divide through by 7. Now, I look at the answers over there, and I don't see anything that looks like what I have. But realistically, the 7 goes to both terms. So I could write it as x over 7 plus 5/7 is equal to y. Okay. Do I have an answer that looks like that? And x over 7 really is 1/7 x. Okay, they're just rewriting equals y. So 1/7 x. I think that one looks good right there. So that's my inverse function. Which is the inverse of f of x equals 2/3 x plus 10? Okay. Again, I'm just going to rewrite this as, I always forget to turn every time I switch a slide, I have to redo my marker. Okay, so I'm going to go y is equal to 2/3 x plus 10. I'm going to flip-flop this, so this is going to be x equals 2/3 y plus 10. And then I'm going to solve this. I'm going to subtract 10 from both sides. So I end up with x minus 10 is equal to 2/3 y. Now, you know, it all depends on how you want to do this. I would probably multiply through by 3 first. So that would give me a 3x minus 30 is equal to 2y. And then I would divide through by 2. And I'm just going to divide each term by 2. So I end up with 3x minus 15 is equal to the inverse function. So 3/2 x minus 15. Uh-oh. Did I make a mistake here? I don't see a 15. Oh, they pulled the 3/2 out of there. Sneaky little guys. All right, let's see here. So if I factored out a 3/2 here, oh boy, that does not. Okay, so, all right. So I'm not going to do it this way. I'm going to go back to where I had x minus 10. I should have looked at the answers first. Is equal to 2/3 y. All right. So I'm going to, since it's a fraction, in order to get rid of that fraction, I can multiply. Now, the way I did it, this is true. I mean, this is absolutely true. But I take a look at the answers and like, okay, forget it. So if I multiply by the reciprocal on both sides, so I'm going to multiply by the reciprocal on both sides. So the 2/3 crosses out the 3/2. So y is equal to 3/2 x minus 10. Now, if you don't agree with me, multiply through here. Okay, that would give me 3/2 x minus 3/2 times 10. That gives me 30 over 2, which is 15. So it is the same answer that I had. It's just they have it written in a different form. So I'm going to go with letter B here for my answer. All right. So this week, remember, 2 things that you have to be able to. You have to be able to transform functions, and you have to be able to do inverse functions. I hope this helped, and I hope you guys all make it to the help session on Monday from 10 o'clock to 11. Hope to see all of you there.